Computers might seem very smart, but they are actually just boxes that follow instructions very quickly and accurately. As intelligent humans, we can get them to carry out different tasks by writing programs or lists of instructions. Computers can't think. A computer won't do anything by itself. It's up to the computer programmer to give it instructions. Write a program. You can tell a computer what to do by writing a set of very detailed instructions called a program. Each instruction has to be small enough that the computer can understand it. If the instructions are incorrect, the computer won't behave the way you want it to. Programming languages. Computers can only follow instructions in a language they understand. It's up to the programmer to choose which language is best for the task. There are a huge range of programming languages to choose from. Each one can be used for different tasks. Here are some of the most popular languages and what they are often used for. C. A powerful language for building computer operating systems. Ada. Used to control spacecrafts, satellites, and airplanes. Java. Works on computers, cell phones, and tablets. Scratch. A visual language that's ideal for learning programming. MATLAB. Ideal for programs that need to carry out lots of calculations. Ruby. Automatically turns lots of information into web pages. JavaScript, a language used to build interactive websites. Python, a text-based language that can be used to build all kinds of things. All programs are finally converted into binary code, a basic computer language that uses only ones and zeros. A programmer must learn to think like a computer. All tasks must be broken down into small chunks so they are easy to follow and impossible to get wrong. Thinking like a robot. Imagine a cafe where the waiter is a robot. The robot has a simple computer brain and needs to be told how to get from the cafe kitchen to serve food to diners seated at tables. First, the process has to be broken down into simple tasks the computer can understand. Waiter Robot Program 1. 1. Pick up food. 2. Move from kitchen to diner's table. 3. Put food down. Disaster. Using this program, the robot grabs the food from the plate, crashes straight through the kitchen wall into the dining area, and puts the food on the floor. The instructions weren't clear. We forgot to tell the robot to use the door. It might seem obvious to humans, but computers can't think for themselves. Waiter Robot Program 2. 1. Pick up plate with food on it. 2. Move from kitchen to diner's table by move to door between kitchen and dining area. Move from the door to the table. 3. Put plate down on table in front of diner. This time we've told the robot waiter to use the kitchen door. It makes it through the door, but then hits the cafe cat, trips, and smashes the plate on the floor. Still not perfect. The robot doesn't know how to deal with obstacles like the cat. The program needs to give the robot even more detailed instructions so it can move around safely. Waiter Robot Program 3. 1. Pick up a plate with food on it, holding it level at all times. 2. Move from kitchen to diner's table by move to door between kitchen and dining area, checking for obstacles and steering around them. 3. Put plate down on the table in front of the diner. Success at last? In this version of the program, the robot successfully delivers the food to the diner, avoiding any obstacles. But after putting the plate down, the robot remains standing at the table while food piles up in the kitchen. Finally, the robot can deliver the food safely, but we forgot to give it instructions to go back to the kitchen and get the next plate.